Hey guys, welcome to today's lesson. I hope you're well. Hope you're enjoying your Sunday down at Field Studies Camp. Today we're looking at the product of functions. Okay, so last lesson we looked at the addition and subtraction of those functions where we simply found the two y values for an x coordinate. We either added them together or we minus them off each other. Today we're simply doing the same process, but we are multiplying. Okay, for the most part, this will be pretty straightforward. Remember, it doesn't really matter in this case which order the graphs are in. Addition is very similar because whatever you times left and right will be the same. So 2 times 3 and 3 times 2, they both equal 6. The only one that we have to be careful of course, is that subtraction question where 4 minus 2 and 2 minus 4 would give you different results. Anyway, so let's have a crack at look at this graph. Now, first of all, we know that we're looking at the product of this function, which means we are multiplying the graphs of f of x and the graphs of g of x. Now, in theory, in this particular question, we know what those two functions are. Now, sometimes you'll know that, and I guess you might say, can I just factorize x squared minus 4 to make it x minus 2x plus 2 and have x minus 2 there, and I can now just plot my roots, which is going to be 2 and negative 2, and go from there. And the answer is yeah, you could. Like I said with those other graphs, most likely you could do that. However, probably in examination, you're not going to be given the actual function. You'll just be told it's f of x and g of x and find p of x. So you need to know how to do this graphically. Now, similar to when we were looking at the addition and subtraction, there are some important points here that might assist me. But basically, if you just take an x coordinate and look at the two y values and times them, and you keep on doing that through a number of periods, you're going to find your graph anyway. But there are some things that I might look for to make things easier. So, first of all, can you think about what might be the most important point to plot first? Well, for me, it's my x and my x-intercepts. Okay, why? That's because at x equals 0, y equals 0. And that means if I times the two y values together, in this instance on the left-hand side, it'd be 0 times, what's that, negative 4? The answer would be 0. The right-hand side, 0 times 0 equals 0. In fact, we know that if I times 0 by any number at all, the answer will also always equal 0, which basically means that any of your x-intercepts on either function, when you have a product of those two functions, the intercepts will also be there. So in this case, I only have two x-intercepts, and we actually saw that by doing it algebraically as well. It's negative 2 and positive 2. So first things first, when you're looking at product of functions, look for your x-intercepts. The second thing I might look for would be the points of intersection. Okay, so I'm going to look at the point of intersection on the left-hand side of my graph. We have the value of negative 1 and what's that, negative 3. Okay, for both of those. So that means the y value will be minus 3 times minus 3. And we know that when we multiply two negative numbers together, or square that number in this instance, we're going to get a positive result. So I'm going to put my positive 9 up here, and I sketch my graph up there. Okay, so I currently have 3 coordinates on there, and I can start to see how my graph is going to look like. But there might be a few extra points I might put on there. For me, the y-intercept, I quickly look at it and see if I can plot that. We have a negative 2 times a negative 4. That's positive 8, so I'm going to plot that up there. I'm almost confident about how my graph's going to look, okay? Except I might just look for one more point. Let's have a quick look at maybe the point 3. For x equals 3. So we've got 1 times 5, and that equals 5. And that's another important one because when I times 1 by any number at all, okay, it's just going to be that other number. Likewise, if I times a negative 1 by that number, if it's a positive, then it remains with a negative. If it's a negative, it goes to positive. So it's not as easy to judge. But in this instance, it doesn't move. And I'm pretty confident now that I've got a graph that looks like this. So let's have a little bit of a sketch. Okay, now I've got a bit of advantage here because I knew what the actual function was. I knew that this was going to be a cubic because I expanded it out. So you might not always have that luxury. So how did I know that's where my turning point was, certainly at x equals 2? Well, I can certainly see to the left of that, I have 2 negative y values, which I know has to be positive. Likewise, to the right-hand side of that x-intercept, we have 2 positive y values, which are always going to be positive. Therefore, I knew that they had to be positive on both sides, which meant I had a turning point. Okay, and likewise, you could do that same thing for the left-hand side turning point as well at y equals 9 and x equals -1. That's basically it. Look, worst case scenario, as I said before, just find any two y coordinates and times. And your graph comes out pretty quickly. Now, the only other thing would be looking at this graph, perhaps you might ask the question about the asymptotes. What might happen when you have a vertical asymptote versus a horizontal asymptote? Well, let's have a little look at this question. Okay, I have a vertical asymptote straight through x equals 0. Now, the only way for me to get two results times to make that 0 is if one of those numbers is 0, right? And we know here at y equals 0, my graph does not exist. Therefore, I can't times, if I've got my 1y value and times by any other number, the only way for that to be a 0 answer, of course, is that I have a 0 there, which means this has to be an asymptote, x equals 0, because I can't times it by anything there. Now, other numbers might differ, okay? But in this instance, that's it. Now, let's look at our important points first of all. For me, we know those two x-intercepts are important. We've got them there. We know 0 times anything makes 0. Okay, so there we go. The other important points for me are going to be my intersection points, my points of intersection. So I'm going to look on the right-hand side, my first quadrant, this point here. That's the coordinate of 6 and 4. Okay, so both y values have a value of 4. So what's 4 squared, or 4 times 4? That makes 16. Beautiful. What about my point of intersection on the left-hand side? Well, we've got -1 and -3 by the looks of things. Now this one, because they're both negatives, we know we'll make it into a positive. -3 squared is positive 9. That's where I get my point there. And we can start to see how this graph is going to look. Now, just be careful. I sometimes do it, as you've seen. When I find a point in this section, I kind of put a little dot there. I'm trying to give emphasis to that. Just make sure that you don't have 2 points on the same x value there. Okay, now, I know what this graph is going to look like. You might not, okay? But certainly we could plot a few more points if we weren't sure. For example, we might look at, let's say, -6. Okay, so that's a positive 2. And then we have a, what's that going to be? 5, 6, 7, 8, and -8. So positive times a negative is always going to be negative. So that's going to be -8 times -2 is -16. It's down here somewhere, right? I'm going to get rid of those 2 points there. And the thing what you might notice, because these values are always negative and these values are always positive, you're always going to have negative results, which means it's never going to kick back up again. Which means, because I've got my asymptote there, I've got this graph that kind of looks like that. Okay, so it kind of looks like that. Kind of like a sideways exponential. It's approaching our y-axis there, okay, or approaching x equals 0. Important to note, gents, when you have product with graphs, as x approaches 0, if your f of x approaches 0, your new product, your p of x, will approach 0 as well. And that's the same as g of x. Okay, they'll all approach the same points, and they're all approaching towards that y-axis. Left-hand side, so right-hand side, I've done that now. Again, if I wasn't sure, I think I know what's happening here, but I'm going to look at, let's say, -1. -1 times positive 10, well, that makes -10. So it comes down here. And so these ones between 0 and 2 will always be negative because we have a negative and a positive. Likewise, to the right of that, it's always going to be positive because I always have these positive graphs on both sides. So for example, we know that 4 by 4 is 16. If I look at x equals 10, that's like 3.5 times 8. So it's going to be another positive number. So I'm going to sketch my graph. There we go. And again, you can see that all of these graphs are approaching infinity, okay? Approaching x is infinity, and yeah, you can see what happens, what was sort of going on. Look, gents, that's pretty much it. Like as I said, it's not that hard. It's very similar to the addition and subtraction of your two graphs. All else fails, just find your two y values for each x coordinate and times them and plot them and start to sketch a graph. Now, Mam has put down a number of things like she has for the other two graphs for sums and differences, and I'll just reiterate these facts. So first of all, for a product of two functions, we're timesing them together. Okay, we know that. For each x value, it remains the same, but it's the two y values that we multiply together. Okay, we know that. Perfect. Fx or g of x has a 0, okay, then automatically p of x has to have a 0, which means we have x-intercepts. We showed that. If fx or g of x equals 1, then when you times them together, the p of x will be the other function. So for example, we said 1 times 5 is 5, or 1 times 4 is 4. Okay, we know it doesn't change. If one is -1, it's often going to be the opposite of what the other one is. Okay, if one's negative, then they're going to become a positive. If one's positive, then the times together become a negative, sorry. So we can see again how that works. Fx and g of x is the same sign, then p of x will also be greater than 0. F of x and g of x are opposite signs. Okay, it's less than 0. Think about your multiplication things. Mixed means minus, and then they're the same sign, plus. Same sort of thing because you times these things together. And I showed you before that f of x approaches 0 and g of x approaches 0, then p of x will also do the same thing. If f of x approaches infinity or negative infinity, p of x will do the same thing. Basically, for me, gents, the biggest thing here is if you're not sure, work on your zeros first, your intercepts, your points of intersection, and then just find some y values and times them and plot them and see how you go. I hope this was useful. I hope you're having a good time down there. Please move on now to make sure you have some notes in your book. And then, of course, that you can start working on some of those exercises. Any problems, please feel free to drop me an inbox on Canvas, or you can do the same thing with MAM. Have a wonderful day, boys, and I'll see you next week.